grade 9 students. Today also I'm here to teach you another new topic. That's chapter 7, Axioms. So before we start this, we'll see certain things. Now think about when you throw a stone up, what will happen? What do you know about that? It will definitely come down. And if you want to touch fire, what happens? You will be burnt. So you don't want to touch it. And when you take water in a river, always flows downwards. So these are absolutely certain things. So you don't need to do the proof. So you don't want to touch the fire. So in mathematics, axioms are something like that. So we'll see what are axioms and what are the terms related to that. So what are axioms? Axioms are statements which are considered to be self-evident and are accepted without proof are called axioms. So it's important that you don't need to do that. So without proof, we know that it's absolutely true. Quantities. Now when you learn about axioms, you need to know what are quantities. So we can take length, width, area, any variable as quantity. So width, area, you know already these terms, volume, radius, velocity, force are defined as quantities. So we need to learn 5 axioms in this lesson. So here first axiom, quantities which are equal to the same quantity are equal. What it means? Think about, you have x value as 10 and also y is also 10. What can you say about x and y? If you want to find out the relationship between x and y, what can you say? Both are the same. So quantities which are equal to the same, that means same 10 value, both are equal. So here x equals 10, y equals 10. So we can write x equals y. So in general, what can you say about this? So if you have any quantity a and b and c is the value of the quantity. If a equals c and b equals c, what can you say about a and b? We know that a is equal to b. So this is the first axiom you need to know. Now we'll apply that axiom in several situations. The mass of Sarath is 50 kilos. Ajit's mass is 50 kilos as well. What can you say about mass of Sarath? That's equal to mass of Ajit's. So both are equal. Now take this example. You have given a triangle ABC and the lengths are given. AB we know 8 centimeters. What about AC? AC also 8 centimeters. So both are equal. So what can you say from this? We can say AB is equal to AC. Look at this one. You have given lengths. So AB, what's the length? 7 centimeters. And what's the length of CD? CD is 7 centimeters. So what can you say about that? Both are 7. We can say AB is equal to CD. Another example, you have given two triangles ABC and PQR. We'll take perimeter of ABC. What's perimeter means? Adding outer length. We'll find out perimeter, that's 10 plus 8 plus 12. So what's the value? 20 plus 10, 30 centimeters. PQR triangle, what's the perimeter of that? 9 plus 8 plus 13. You get same answer. So 13, so you get 30 centimeters. So these two are the same. So what can you say about the perimeter of ABC triangle? That's equal to perimeter of PQR triangle. Take this example. The length of one side of the square ABCD is 12 centimeters. If the perimeter of the square is equal to the perimeter of the PQR triangle, find the value of x. So you need to find out the value of x. So what's the perimeter of the square? We know four sides are there, all are equal. So 12 plus 12 plus 12 plus 12, or you can multiply this by 4. You get 48 centimeters. What's the perimeter of the triangle? If one side is x, here can you see all three sides are equal. So x and x and x, you get 3x. X plus x plus x, you get 3x. Now in the question it says the perimeter of the square is equal to the perimeter of the triangle. Both are equal. Then we can say these two are equal. So 48 is equal to 3x. Then what can you say about x? So you can divide this by 3 and find out x. X is equal to 16 centimeters. This question, show that POA is equal to QOB. What can you say? What's POA value? POA value is given 40 degrees. What's QOB? That's 40. So both are equal. So what can you say about these two angles? So you can say POA angle is equal to QOB. So easily you can see by looking at the values. Next one, if AOD, this one is given equal to COB, this one. Find the value of x. So what is AOD? That's given 150 degrees. What's COB? X and x, you get 2x. Here, if these two are equal, you can write AOD is equal to COB. That's given. So if these two are equal, we can plug these values. So 150 degrees is equal to 2x. Now divide by 2. You get 75 is equal to x. So you can easily find out the value of x using the axiom 1. This one, you have given a diagram and it says if ABC angle is equal to BCD. This one, find the value of x. What's ABC? It's 2x. What's BCD? That's given 80 degrees. But we know ABC is equal to BCD. That's given in the question. So we can equate ABC is 2x. This is 80 degrees. So divide this by 2. You get x is equal to 40 degrees. Now we'll look at axiom 2. It says quantities which are obtained by adding equal quantities to equal quantities are equal. So that means when you take an equation, 10 is equal to 10. So that's equal quantities. When you add 5 to both sides, this becomes 10 plus 5, 15. And here also 10 plus 5, 15. So the equal amounts also equal. When you add same quantity to equal quantities, both are again equal. So the equation obtained by combining two sets of equations is equal to two sets of equations. So here, for example, if we say A equals B, add C to both sides like 5, what happens then? A plus C is same as B plus C. In general, we can say, okay, we have one equation A equals B. We have another equation X equals Y. So we can combine these two. When you add X quantity to this side, you get A plus X. Then when you add B and Y, you get B plus Y. So in this axiom, we are thinking about addition. So we'll try to apply this axiom in examples. Take this example. For the information of above image, show that AC is equal to BD. What can you see at once? We can see AB is 10. So we can see AB is 10 centimeters. What about CD? CD also 10. Now from these two, using first axiom, I can write AB equals CD. That's axiom number 1. Then I want to add this BC quantity to both sides. AB plus BC. Then BC plus CD. So what you get? AB plus BC, what you get? That's AC. BC plus CD, you get this part. That's BD. So what can you say about that one? AC is equal to BD. So this is using axiom 2. AOB is equal to COD. Then that's given. Show that AOC is equal to BOD. Okay, so what's given? AOB is equal to COD. That's given. Now I want to add this angle to both sides, BOC. AOB plus BOC. COD plus BOC. What you get? When you add AOB plus BOC, we get AOC OC, this full angle. COD plus BOC, you get this full angle, BOD. So we can easily show that AOC is equal to BOD. Look at this example. According to the image information, OBA, that's this angle, is equal to OAB. That's given X. So what is OBA? That's given as OAB. And I can put this is as X. Then what's the other information? It's given OCA. OCA. This angle is equal to this one. So already given this as Y. So I'll write down OCA is equal to OAC. That's equal to Y. Now I want to add these two. So I'll add the left hand side, OBA plus OCA. And this side also you need to add OAB plus OAC. Now what happens? OBA is X. This is Y. Here also X, OAB is X, OAC is Y. Now when you look at the diagram, what's that angle? What's OBA? OBA, this angle, and OCA angle. Here, this is the sum of these angles. Now, look at the right hand side. What can you write? OAB plus OAC, this angle. So, I can mark it. I need this full angle. So, what's that? X plus Y or BAC. So, I can write this one is BAC. So, this one I can write as it is. OBA plus OCA is equal to BAC. Look at this one. The center of the circle is O. OAB. This angle is given equal to OBA, already given as X. Again, OBC, this angle is given to OBC is equal to OCB. That's why. Show that OAB plus OCB equals ABC. So, what's given? It's given, we'll take different color. What's given? OAB is equal to OBA. That's X. That's given. Then OCB, this one, is given OBC. That's Y angle. That's also given. Now we'll add these two. When you add these two, OAB plus OCB. When you add these two, what happens? This becomes OBA plus OBC. What is the right hand side? OBA and OBC, this full angle. What can you write about that angle? You can write ABC. Instead of this, I can write this is ABC angle. So, that's the statement that we need to prove. So, you get OAB plus OCB is equal to ABC. So, what's the axiom? The addition rule. Axiom number 2. axiom number 3 now. What it says, quantities which are obtained by subtracting equal quantities from equal quantities are equal. Now think about this example. We know 10 is equal to 10. Then subtract 3 from both sides. Then that statement also true. 7 and 7. So for example, in general, if two quantities A and B are equal, subtract any quantity C from both sides, then A minus C is equal to B minus C. Then in general, what can you say? Two equations are there, A equals B, X equals Y. When you subtract, left hand side you get A minus X and right hand side you get B minus Y. Now we'll look at some examples related to axiom number 3. In this one, it says a straight line PS is equal to RQ. This value is equal to this one. So you are asked to show that PR is equal to SQ. Okay. So first we'll write down the given information. PS is equal to RQ. Now I want to subtract RS from both sides. Subtract RS from both sides. So what happens? PS minus RS. RQ minus RS. Now look at the diagram and see. What is PS minus RS? From this big distance, when you subtract, you get PR. What about the other side? RQ minus RS, you get SQ. So that's what we need to prove. This one, in this figure, PQY, this big angle is equal to XQR, this one. So you are asked to prove that PQX is equal to YQR. So what's given? It's given PQY is equal to XQR. That's given. Now we'll subtract this one from both sides. XQY. So I can write XQY is equal to XQY. And then subtract the two equations. So you get PQY minus XQY. This side you get XQR minus XQY. Now look at the diagram. PQY minus XQY, you get PQX or XQP. So PQX. We'll write this way because you need to show that. That becomes PQX. What about the other side? XQR. This bigger triangle, this bigger angle XQR minus this, what you get? YQR. So this part is YQR. So what's the axiom we used here? Axiom number 3. This question, in the figure, PBC angle is equal to QBC. Show that ABP, this angle is equal to ABQ. Okay, but we know ABC angle is equal to ABC. So that's a straight angle. So same angle you can equate. Now, what's the other given information? PB PBC angle is equal to QBC angle. That's also given. Then when you use axiom 3, subtraction, we get ABC angle minus PBC here, ABC angle minus QBC angle. This is axiom 3. Now, when you subtract from 180, when you subtract, you get the other angle. So, what's that? You get AB. P. ABP angle is equal to this side. When you subtract this one, you get ABQ angle. That's what we need to prove. This example, in this figure, area of ABP is equal to area of ACP. This side is equal to this side. And area of QBC, the area of QBP, this one, is equal to that. So, I'll highlight this area is equal to QCP, this one. Then you are asked to show that the area of ABQ, the other part. So, obviously we can see this is using axiom 3, subtraction. So, this is given ABP, the big triangle areas are equal. Then QBP also equal. Now, use axiom 3. That means subtraction. ABP triangle minus QBP triangle. What happens? QCP triangle. So, this side, this big triangle minus this part, you get ABQ triangle area. What about the other side? This whole big triangle minus this part, AQC triangle. So, the area of AQC. So, you get area of this is equal to area of this. Now, we'll learn axiom 4. So far, we did axiom number 2, addition, and then axiom number 3, subtraction. Now, what it says in axiom 4, products which are equal quantities multiplied by equal are equal. So, that means here we take multiplication. Think about this statement, 10 is equal to 10. Then when you multiplied this number by 2 both sides, you get 20. That's also equal. In general, if A quantity is equal to B quantity multiplied by a C quantity, so A into C is equal to B into C. So, what's the axiom number 4? When two quantities are equal, so two equations, when you multiply together, that's also equal. So, A into X, AX is also equal to BY. Now, we'll try to apply multiplication in several examples. Now, we'll look at examples related to axiom number 4. PQR is a triangle if PA is equal to ABBQ and also PC is equal to CDDR. Find the relationship between PQ and PR, and also given that PA equals PC. This is PA is equal to PC. So, what's given? PA equals PC. Now PA equals AB. So if this is these three also equal. PC is equal to CD DR. Now we need the relationship between PQ and PR now. So we get three parts like this. So we'll multiply both sides by 3. What happens? 3 PA is equal to 3 PC. So 3A PA. So 3 PA, what you get? You get PQ. So PQ is equal to 3 PC means this length. That's PR. So we can say that PQ is equal to PR. This example, ABCD is a quadrilateral. AP, PQ, QR, RB all are equal, and DK, KL, LM, MC all are equal. And here, can you see these also equal? Show that AB is equal to DC. We know that AP equals DK. We can see that these all are equal lengths. How many parts like this? 1, 2, 3, 4 parts. Here also 4 parts. So we can multiply one part by 4. So multiply by 4, you get 4AP is equal to 4DK. So 4DK, what you get? DC. Here this side is not DK. So what you get here? 4 times AP, this one. 4 times AP, you get AB. What's 4 times DK? 4 times DK, that's DC. So we can easily show that AB equals DC using which axiom? Axiom number 4, multiplication rule. Look at this example. A circle centered on O is divided into 6 regions of equal area. If APO, this region is equal to BOS, show that the area of the APQB quadrilateral is equal to the area of the quadrilateral ARSP. We already know that these two are equal. That's given. Multiply by 3. What happens? 3 times the triangle AOP is the area, and 3 times the area of BOS. What happens? 3 times when you multiply same areas, because all these are 60 degrees. So equal area is given because equal, 6 regions of equal area. So what can you say? When you multiply by 3, you get this part. APQB quadrilateral is equal to BOS. When you multiply 3 times, you get this quadrilateral. So what's the quadrilateral? ARSB. ARSB quadrilateral. Now we'll look at the last axiom. That's axiom number 5. We'll see what it says. Quotients which are equal quantities divided by non-zero equals are equal. So that means we know 10 is equal to 10. Divide by 2 both sides. You get 5 and 5. So those two quantities are equal. So in general, if two quantities A and B equal, divide by n quantity. So n quantity cannot be 0. Why? You can't divide by 0. When you divide by 0, you get an error term. You can't use the calculator to find out that. So we call undefined. So n should be any number not equals to 0. So this is about division. So axiom 5 says when you divide by a quantity, the quantities are equal. So in general, if A equals B, X equals Y. You divide the two equations, then A over X becomes B over Y. Now we'll try to apply this in several examples. The perimeter of the regular hexagon PQRSTU is twice the perimeter of the equilateral triangle ABC. So this twice is this. And it says if the perimeter of ABC is 36, so this is given 36 centimeters. Show that AB is equal to PQ. We'll find out. What's the perimeter? Here it says the perimeter of the hexagon is 2 times the perimeter of ABC. So this is multiplication. And divide both sides by 6. What happens? You get PQRSTU quadrilateral divide by 2 times perimeter of ABC divided by 6. Here also perimeter. So this side is given. Perimeter of ABC is 36. So we'll plug that value. 2 into 36 divided by 6 is equal to perimeter of PQRSTU divided by 6. Perimeter of this. So how many sides are there? 6 sides. When you divide by 6, you get one side. So instead of this part, you can write PQ, one side. What about this side? When you simplify, you get 2, you get 3 and 36 divided by 3, you get 12. We found one side PQ is 12. Now what about one side of the triangle? If 36 for all 3 sides, what's one side? What's the length of AB? AB is 36 centimeters divided by 3. That's 12 centimeters. What can you say about these two statements? AB also 12, PQ also 12. So we can say AB is equal to PQ length. So that's what we need to show. So the length is 12 centimeters as well. Further applications of the axioms in algebra. So far we discussed axioms in geometry. Now we'll see axioms in algebra. So this is solving linear equations. So here if it's 7x minus 5 is 30, add 5 to both sides, what happens? So that's axiom number 3. So you can write this one as 7x minus 5 is equal to 30. So I'm adding plus 5 both sides. So what am I getting? I'm getting 7. X here, 30 plus 5, 35. Now to get x, I need to divide both sides by 7. So I'm dividing both sides by 7. That's axiom 5. Division is axiom 5. So you get x equals 5. So we are using axiom 3, that's addition, and division is axiom number 5. Now we look at this one. 3x plus 6 over 2 equals 15. So you need to solve for x. So what's the first step? I can multiply both equations, both sides by 2. 3x. I can multiply both sides by 2. So that's axiom number 4, multiplication. So I'm multiplying both sides by 2. So what you get? 2 get cancelled out. You get 3x plus 6 is equal to 30. Now what's the next step? We need to get rid of this 6. I'm subtracting 6 from both sides. That's axiom number 3. You get 3x is equal to 24. Now to get x, you need to divide. That's axiom number 5. Divide by 3. You get x equals 8. So in this equation, we used 3 axioms. Look at this example. 5x plus 4 over 8 equals 3. What's the first one? We have to multiply by 8. So this side also multiply by 8. You get 5x plus 4 is equal to 24. This is axiom number 4 because multiplication is axiom number 4. Now what you have to do? You have to subtract 4. That's axiom number 3. So you get 5x equals 20. Now we need to divide this by 5. So we'll use axiom number 5. So divide by 5. You get x value. So what's the x value? X value is equal to 4. 20 divided by 5 is 4. So division is axiom number 5. So here also we use 3 axioms. Here normally when you solve equations, you follow these. We are not mentioning this is axiom 1 or 2 or 3, but only for this lesson you can write down which axiom is applied, but not for other sections. We'll look at this one. Q is the midpoint of PR. Q is the midpoint of PR. So that means this length is equal to, I'll mark with 3, this length is equal to this length. And it says PQ is 8 centimeters. And PR and BC both are equal. And you are asked to find out the length of BC. So we'll find out the length of BC. We know PQ is 8 centimeters. What about PR? So Q is the midpoint. When you multiply by 2, you get PR is 16. So 8 and 8, you get 16 centimeters. Multiply by 2. But we know PR is equal to BC. That's given in the question. So what can you say about this one? So PR is equal to BC, but we know PR is equal to 16 centimeters. So what's BC? BC is also 16 centimeters. Now we'll solve this algebraic expression. So what's the first thing we have to do? We have to multiply by 3. That's axiom number 4. Then 3 get cancelled out. You get 5x minus 2 equals 18. What's the next one? You need to remove minus 2. So you add 2 to both sides. That's axiom number 2. So when you add, you get 5x here. 5x equals 20. Then how you find x? You need to divide this by 5. So division is axiom number 5. So when you divide, you can find x. X equals 4. 20 divided by 5, you get 4. Now we'll try to solve this equation. You get brackets. So what's the first thing we have to do? We have to remove brackets. So first we'll remove 3 times 2x, that's 6x. 3 times 2 plus 6. Minus 5 times x, minus 5x. Minus 5 times plus 2, you get minus 10. That's equal to 0. Now like terms you can add. 6x and minus 5x, you get x. 6 and minus 10, you are getting minus 4. Now, what's the axiom we have to use now? Minus 4, you have to get rid of this equation. So, you are adding plus 4 to both sides. That's axiom number 2. When you are adding a number, so you get x here, x is equal to 4. So, we did 5 axioms. So, what are the 5 axioms? First one is if the two quantities are equal to each other, then the other quantity is also equal. When you add two quantities, the addition is also equal. When you subtract two quantities, the subtraction also equal. When you multiply quantities, multiply also equal. And when you divide quantities, the quantities after you divide is also equal. Now we'll apply those 5 axioms in examples and exercises. Example number 1, in the triangle ABC, it's given AB is equal to AC and AB is equal to BC. If AC equals 5, then determine the perimeter of the triangle ABC. Obviously, we can see this is an equilateral triangle and perimeter is 15 centimeters. But we will try to prove that. We know AB equals AC. That's given. Again, we know AB equals BC. Now, two equal quantities. What can you say about this? We can say AB is equal to AC as well as AC and BC also equal. This is axiom number 1. Now, all three sides are equal. One side is 5 centimeters. It's given AC is 5 centimeters. So, the perimeter of ABC triangle is 5 times 3. 15 centimeters because all three sides are equal. Example number 2, in the figure given below, XBY. This angle is equal to ABX. ABX, this one is equal to this one. XBY. This angle is equal to CBY. Find the relationship between ABX and CBY. So, we can easily see all are equal. But we need to show the steps. So, what's the first step? XBY is equal to ABX. That's given. XBY is also equal to CBY. That's also given. Now what can you say about these two quantities? These two are equal. So we can say ABX is equal to CBY. And also that's equal to XBY. All three angles are the same. So what can you say about ABX and CBY? Both are equal. So therefore, ABX is equal to CBY. Exercise 7.1. The straight lines AB and CD intersect at X in the figure DXB. This angle is equal to BXY. This angle. If AXC, this is given 70 degrees, find the magnitude of BXY. BXY, this angle. We can say that DXB is what? DXB is BXY. It's given. These two are equal. But we know that these two angles also equal. What's BXD? Or DXB is also equal to AXC. That's 70 degrees. What are those? Opposite angles. Opposite angles. So this is also 70 degrees. So what can you say about these two? These two also equal. So BXY is equal to AXC. That's equal to 70. So what's the magnitude of BXY? Therefore, BXY is equal to 70 degrees. Question number 2. In the parallelogram PQRS, PQ equals PR. PR, this one. And also PQ is equal to PS. Based on its sides, mention what type of triangle PSR is. What can you say? That's an isosceles triangle. PQ is equal to PR. That's given. And also PQ is equal to PS. Given information. Using these two, that's axiom number 1. Equal quantities are also equal. That means PR is equal to PS. Axiom number 1. So what can you say about PR and PS? Both are equal. So two sides are equal in the triangle. So that means PSR is an isosceles triangle. Question number 3. The points A and B are located on the circle with center O such that OA is equal to AB. Based on its sides, mention what type of triangle ABO. What's the given information? OA equals AB. Now this is a circle. OA is the center. What are those length OA and OB? Those are radii. Both are equal. So that's radii. Now what can you say about these two? Same quantity equals to these two. So therefore AB is equal to OB. That's axiom number 1. Now this is also equal and this is also. Now you can say therefore AB, OB, OA, all three sides are equal. What type of triangle? AOB or ABO. ABO triangle is an ABO triangle is an equilateral triangle. Example number 1. In the figures given below, ABD is equal to PQS, CBD is equal to SQR or RQS. Show that ABC is equal to PQR. Okay, so we'll write down the two equations given. ABD angle is equal to PQS. That's given. CBD angle is RQS. That's also given. Now we'll add these two. When you add these two, you get ABD plus CBD should be equal to PQS and RQS. That's axiom number 2, because addition of two equations also equal. Then what can you say about ABD plus CBD? You can write this is as ABC. What about this one? PQS and RQS, you get PQR. So these two angles also equal. Exercise 7.2. The point O is located on the side XY of the triangle XYZ such that OZ is equal to OY. Show that XY is equal to OZ plus OX. So we'll start from the given information. It says OZ equals OY. That's given. Now we'll add OX to both sides, or we can write OX is equal to OX. Now we'll add these two. What can you write? OZ plus OX is equal to OY plus OX. What is OY plus OX? That's XY. So you can write this one as XY. So what you get here? We get OZ plus OX is XY. So I'll write other way around. So XY is equal to OZ plus OX. Question number 2. The point D is located on the side AC of the triangle ABC. ABD this angle. I'll use black. This angle is equal to BCD. This angle. CBD, this angle. CBD is this angle is equal to BAD. BAD is this angle. These two are equal. So show that BAD plus BCD equals ABC. So this is adding two equations. So we'll first do BAD, or we have BCD. So BCD is equal to ABD. That's given. Then what's given? Other information. CBD. CBD is, we'll write this way. CBD angle is equal to BAD. That's also given. When you add these two equations according to axiom number 2, you can write BCD plus BAD is equal to ABD plus CBD. Now what is ABD plus CBD? That's ABC angle. So we can rewrite this as BAD first. We'll write BAD plus BCD is equal to ABC. Question number 3. The points X and Y are located on the sides AB and CD, respectively, of the quadrilateral ABCD such that AX is equal to CY. So these two lengths are equal and the other two lengths are equal. And BX is equal to DY. Show that AB equals CD. So this is axiom number 2, adding two equations. So we'll write down AX is equal to CY, that's given. And BX is DY, that's also given. Now we can add these two equations. AX plus BX, AX plus BX is equal to CY plus DY. What is AX and XB or BX? You get AB. What is CY and YD? That's CD. So these two lengths also equal. Example number 1. The straight line segments AB and CD intersect at P. XPD. This angle is equal to BPY. This angle. Show that APX angle is equal to CPY. This angle. Now we'll look at the given information. It's given XPD is equal to BPY. But what can you say about this angle? This angle and this angle. Both are equal. Those are opposite angles. So I can write APD angle is equal to CPB angle. Opposite angles are equal. But the given information is XPD. is equal to, XPD is equal to BPY. That's given. Now we'll subtract these two. APD minus XPD is equal to CPB minus BPY. That's axiom number 3. So when you subtract, what happens? The bigger one, subtract this one, you get APX there. So from this you get APX. From the other side you get CPY. So these two sides also, these two angles are equal. That's the first part. Second part, it says if APD is 95 and XPD is 20, find the magnitude of CPY. So we'll substitute to this equation. It says APD is here, 95. XPD is 20. So when you subtract these two, you get CPY as well as APX. So what's the answer? You get 5 here, 75 degrees is this. So what they ask, what's CPY? So 75 degrees. Exercise 7.3. The points A and B are located on the line XY such that XB is equal to AY. So we'll try to write down. So this is equal to this one. If XY is given 16 centimeters and BY is 6, the whole thing is given 16 centimeters. Find the length of AB. Now we'll try to find out. So what's the given information? XB equals AY. That's given. Now subtract AB from both sides. We'll write AB equals AB and subtract XB minus AB is equal to AY minus AB. What can you say about this? XB minus AB, you get AX. AY minus AB, you get BY. Now, we know BY equals 6 centimeters. So, this is 6 centimeters. So, what's the length of AX? AX is also 6. Now, you can easily find out AB. So, what's AB? AB plus 6 plus another 6 is the total length. That's 16. So, 6 plus 6 is 12. And when you subtract 12 from 16, you get 4. AB equals 4. So, the length of AB is 4 centimeters. Question number 2. The point B is located on the line AC. If ABD, this big length is equal, this big angle is equal to CBE, this angle. Show that ABE is equal to CBD. Okay, so what's given? ABD angle is equal to CBE. will subtract the common one from both. So I want to subtract DBE angle from both sides. What happens when you subtract this angle from this? You get ABE here. What about the other side? Big angle minus the smaller one, you get CBD angle. So we can easily show that by subtracting these two equations. So that's according to axiom 3. Question number 3. In the quadrilateral PQRS, in the figure SPR, this angle is equal to PRQ. PRQ. If QPS, this angle is equal to PRX angle and SPR angle is given already, show that QPR angle is equal to QRX. So it's not hard. So we'll write down SPR angle is equal to QRX. That's given. And again given, which one? SPR is equal to this. And also this bigger angle is SPQ. SPQ angle is equal to XRP or PRX. That's also given. When you subtract these two, what happens? SPQ minus SPR. SPQ minus SPR, you get QPR angle. This side, PRX angle minus QRX. When you subtract bigger one and the smaller one, when you take the difference, what happens? You get QRX angle. So these two also equal. This is according to axiom number 3. Question number 4. In the figure given here, PQY is equal to XQR. This angle. PQR is 110. The whole thing is PQR angle is 110. 110. PQX is 35 degrees. Find the magnitude of RQY. RQY is this small angle. Now we'll see. We know PQY angle is equal to XQR angle. That's given. We'll subtract XQY angle from both sides. What you get? This is axiom number 3. When you subtract bigger and this common one, when you subtract, you get PQX angle here. What about the other side? XQR and XQY angle, you get YQR angle. But we know PQX is 35. So what's the YQR or RQY angle. RQY angle is also 35. That's part 1. So you get RQY is same as this one. So that's 35 degrees. That's part 1. Now we'll do part 2. Find the magnitude of XQY. XQY is this angle. So what can you write? XQY angle is equal to the bigger angle PQR minus 35 and 35. This is 35 also. We found these two angles are equal. 2 times 35. Then PQR angle 110 already given. 2 times 35 is 70. So 110 minus 70, you get 40 degrees. So XQY angle is 40 degrees. Example number 1. The points X and Y are located on the side AB of the triangle ABC such that AX is equal to XY is equal to YB. All three lengths are equal. And the point PQ are located such that AP plus AP is equal to PQ and QC. If AX is equal to AP, find the relationship between AB and AC. So what's given? It's given AX is equal to AP. Now we see 3 equal parts. Here also 3 equal parts. So we can multiply both sides by 3. So 3 times AX is equal to 3 times AP. So 3 times AX, you get AB. What is 3 times AP? You get AC. So what's the relationship? AB is equal to AC. Another example, in the figure given below, AOB is BOC. These two angles are equal. COD angle is equal to this one. It's already given. AOC is also equal to COE, this one. Find the relationship between AOB and DOE. Okay, so here we'll start from here. AOB is equal to BOC. That's given. Okay, we'll take what's AOC. We know AOC is AOB plus BOC. This plus this. But these two are equal. If we put this is A and this is A, what's AOC? You get 2A. We'll take first equation. Then what about this information? AOC is equal to COE. So AOC is 2A. But we know AOC is equal to COE. Given information. Then from these two, you can say COE is equal to 2A. This is equal to 2A. So find the relationship between AOB and DOE. What can you say about that? Now we know these two are equal. That means this is also two-way. So when you divide this by 2, divide both sides by 2, that's using axiom 4. What happens? You get A equals COE divided by 2. So if this is y, this is also y. So when you divide by 2 means you get y there. So COE angle is COD plus DOE, that's both y divided by 2. So y plus y divided by 2 means you get finally y. So this one is equal to y. So A equals y. So A equals y means this angle AOB is A. So AOB angle is equal to y means DOE. DOE angle. So what's the relationship? These two angles are equal. So that's the first step. Then the second one, if BOC is 35, this is 35 given. Find the magnitude of DOE. A and y both are equal. So DOE also 35. So we can write down that AOB is same as DOE. It's from the first part. So AOB is same as here. So this is also 35. So this is 35 degrees. So what's the value of DOE? What's the value of DOE? That's also 35 degrees. Exercise 7.4. The square ABCD and the rhombus PQRS are such that AB is equal to PQ. Using axiom 4. What's axiom 4? Multiplication rule. Show that the perimeter of the square ABCD is equal to the perimeter of the rhombus PQRS. What's the given information? AB, we know that's equal to PQ. We know in a square or a rhombus there are 4 sides. So we'll multiply by 4 both sides according to axiom 4. What happens? Both are equal. So 4 times AB is also equal to 4 times PQ. So what's 4 times AB? 4 times AB is the perimeter of the square. So this is perimeter of ABCD square. That's equal to PQ times 4 means all these sides are equal. And the square also, all sides are equal. That's why we can multiply by 4. You can say this is PQRS rhombus. That's the perimeter. Perimeter of PQRS rhombus. So these two are equal. Part 2, if AB equals 7, find the perimeter of the rhombus PQRS. So that's also 7. So all are equal. So what's the perimeter? Part 2, perimeter of rhombus is, one side is 7, 7 times 4, 28 centimeters for the perimeter of PQRS rhombus. Question number 2, in the triangle ABC, BAX, this angle is equal to XAY and also equal to CAY. All three angles are equal. The pentagon KLMNO MON angle is equal to LOM and LOK. All three angles are the same. If BAC angle, this big angle is equal to KON, this big angle, show that XAY angle is equal to MOL angle. Now we'll try to prove the first one. You are asked to prove that XAY, the smaller angle, is equal to that one. It's given all these three angles are equal. So what can you say about this angle XAY? That's equal to BAX or YAC. So I'll put letters AAA. That's equal to ABX or YAC. I'll put A there. So we can multiply this by 3. When you multiply this by 3, what happens? Multiply this equation by 3. 3 times XAY angle is equal to 3 times ABX angle. Or I can use letter A. So what's the value? I can write 3A. What's 3 times XAY? XAY 3 times, you get the bigger angle. So that's BAC angle. Here, when you multiply this by 3, you get the bigger angle. That's BAC. Here, we know that that's BAC is this. And that's also equal to KON. That's 3A. Now we'll look at the other diagram. We know all three angles are equal. Now what is the KON bigger angle? Bigger angle is 3 times the smaller ones. I'll put Y for smaller ones. So I get 3Y. So 3Y equals 3A. So what can you say about this? 3Y equals 3A means Y equals A. Y means one angle there, A means one angle there. So XAY is one angle here. So therefore, XAY angle is equal to MOL angle. So that's the first part. If XAY, so one angle is 30 degrees. Determine the magnitude of KON. So KON is 3 times Y. Y is same as A. So what's the value of KON angle? KON angle is, the bigger one is 3Y. But we know Y angle is 35. Y angle is 30 degrees. So we can substitute there. So 3 times 30 is KON. That's 90 degrees. Question number 3. In the quadrilateral PQRS, PQ is equal to PS to PQ. 2 times PQ is RS, is double of PQ. The perimeter of the regular pentagon ABCDE is equal to that of the quadrilateral PQRS. Find the relationship between PQ and AB. Okay, what you know about the perimeter? We can write perimeter of ABCDE is equal to perimeter of PQRS quadrilateral. Now, what's the perimeter of ABCDE pentagon? This is a regular pentagon. All sides are equal. We can write in terms of AB. That means 5 AB is the perimeter of ABCDE pentagon. What about the perimeter of PQRS? Here all 3 sides are equal. So if I can write all lengths in terms of PQ, I can simplify. So PQ, PQ, PQ plus 2 PQ. Altogether 5 PQ. So this is equal. Then when you divide by 5, what happens? You get AB is equal to PQ. So that's the relationship between PQ and AB. Then what about the second part? AB equals 8. This length is given 8 centimeters. Find the perimeter of the quadrilateral PQRS. Okay, so we know that AB is PQ. So we can easily find out the perimeter of PQRS. That's 5 times PQ. But we know PQ and AB equal, that's 8 centimeters. So 5 times 8, 40 centimeters is the perimeter of PQRS quadrilateral. Further applications of the axioms. We'll see example number 1. These are algebraic equations. So we'll solve that. So 2x plus 5 equals 13. We'll subtract 5 from both sides. That's axiom number 3. We'll subtract 5 from both sides. What happens? You get 2x equals 8. Then you need to divide both sides by 2. What's the axiom? That's axiom number 5. So you get x equals 8 divided by 2 is 4. Miscellaneous exercise. In the quadrilateral ABCD, AD equals AC. AC. BC is equal to AC. So this is also equal to BC. AB equals BC. AB equals BC. So this is also equal. And AD equals CD. So this is also equal. Show that ABCD is a rhombus. So obviously we can see all sides are equal. So this is a rhombus. But we need to write down step by step. So we'll do that. AD equals AC. but AC is equal to BC. So what can you say about these two axioms? Equal axioms are also equal. So therefore, AD equals BC according to axiom number 1. Then what can you say about the other one? AD equals AC and also AD equals CD. So when you take these two, you can say AC is equal to CD. And also this is equal to AD. This is also axiom number 1. Here you can write this is also equal to AC as well. So all sides are equal. Now you can connect. Here AD is here and here also AD. So all lengths are equal. So therefore AD, AB, BC, CD, all lengths are equal. Therefore it's a rhombus. All sides are equal, and when you take angle, this is an equilateral triangle, so this is 60. This is also 60 degrees. So why we can't say this is a square? One angle is 60 degrees, so it's a rhombus, not a square. Because when all sides are equal, you can write this is a square. But one angle, we'll write that angle is 60 degrees, so not a square. If it's 90 degrees only, you can say that's a square. Question number 2. As indicated in the figure, the point S is located such that PRS angle is equal to SQR. QRS angle is equal to PQS. PQS, these two. By applying the axioms, show that PRQ, that's the bigger angle. So we can see that's axiom number 2, adding 2 equations. So we'll do that. First part, PRS angle is equal to SQR. That's given. QRS angle is equal to PQS angle. That's also given. Now we'll add these two. We can say PRS angle plus QRS angle is equal to SQR plus PQS according to axiom number 2. Now when you add these two, what is PRS and QRS? That's PRQ angle. SQR and PQS angle, you get PQR. So we can easily find out these two are also equal. Part 2. Show that if RPQ is equal to PRQ. This angle, I'll use a different color. RPQ angle is equal to PRQ. This angle. Then all the angles of the triangle PQR are equal in magnitude. What can you say? We know PRQ angle is equal to PQR angle or Yeah, PQR angle. That's in part 1. Proved. And also we know that these two also equal. So we can connect that. RPQ, and this is PRQ. So PRQ angle is equal to RPQ. Now same angle here. So these two also equal according to axiom number 1. So therefore, you can write PQR angle is equal to RPQ. This is same as PRQ. Now PQR is that side angle, RPQ is that, PRQ is this angle. All three angles are equal. So what they want, all angles of the triangle PQR are equal. So we can easily show that. Question number 3. As indicated in the figure, the straight lines AD, BE and CF intersect at point O. If DOE, this angle is AOF, this angle. Show that BOD angle is equal to DOF. So we need to show that BOD is this angle, DOF is this angle. Now we need to show that this is BOD and DOF angles are equal. Okay, so we'll start from here. We know that DOE is AOF. DOE is AOF. That's given. But we know AOF and these two angles are opposite angles. AOF angle is same as COD angle. Opposite angles. Then what can you say about this? These two are equal. Therefore, DOE is equal to COD. That's according to axiom number 1. So we'll put this is A, and we found this is also A. Now when you take BOC angle, these two are equal, those are opposite angles. So we'll take BOC angle is equal to FOE angle. That's also opposite angles. Now we'll add these two. When you add DOE plus FOE, here COD plus BOC. So this is according to axiom number 2, because addition rule. So what's this? DOE plus FOE. DOE plus FOE is FOD. So or DOF. What about the other side? COD plus BOC, you get BOD. So these two angles are equal. So we can show that easily these two angles are equal. Question number 4. In the regular pentagon ABCDE, EAD angle. This angle, I'll use different color. This angle is equal to DAC. This angle, and that's also equal to BAC. this one. And the other side, BCA angle. BCA angle means this one. This angle is equal to ACE, ACE and DCE. These three angles are equal. Show that BCA angle, BCA angle is equal to BAC angle. So we need to show these two are equal. So what it says, it's a regular pentagon. So regular means all interior angles are equal as well as all sides are equal. So what can you say about this? Here equal three angles are there. So when you take A, we take the angle EAB angle. The big angle in the pentagon, that's equal to this big angle, DCB angle or BCD angle. Why? This is a regular pentagon. Now divide both sides by 3. When you divide, you get one angle. So we can write the one here as BCA. Not BCA, BAC. This angle. So when you divide by 3, you get EAB divide by 3 here, BCD divide by 3 here. So when EAB divide by 3, you get BAC angle. What about the other side? When you divide by 3, all these 3 are equal, so you get one angle. So that's equal to BC angle. So these two are equal. Then part 2, if BAC is 36, this is 36 and you are asked to find out CDE angle. So one big angle of the pentagon. So if this is 36, when you multiply by 3, you get the big angle. So that's equal to EDC angle. So EDC angle is 3 times BAC angle. But we know BAC is 36 degrees. So 36 times 3. 3 times 6, 18. 1 remaining. So 108 degrees for EDC or CDE. CDE is the same angle. Question number 5. The point X lies on straight line AB, also AXE. This angle is equal to EXD. EXD angle and BXC. BXC angle is equal to CXD. These two are equal. Determine the magnitude of CXE. So where CXE is CXE, this angle. So you're asked to find out that angle. So we'll do addition and see. We can say according to the given information, AXE angle is equal to EXD. AXE angle is EXD. And we know that CXD angle BXC So we'll use this one as x, this one as y. This is x and this is y. So we need the big angle, that's x plus y, EXC, or we can write CXC. Angle is, according to the diagram, that's x plus y. But we know the AB, we know AB is a straight line, so that's AXB angle is 180. AXB angle is 180. So what's 180? 2x plus 2y is 180. 2x plus 2y is 180. Divide all these by 2. You get x plus y equals 90 degrees. So x plus y is CXE. So what's the magnitude of CXE? That's 90 degrees. In this lesson, we covered 5 axioms related to this topic. What are those? You can add, subtract, multiply, and divide any quantities by another quantity. When you do that, the quantities are equal. So practice all these examples and the exercises in the textbook and make sure that you apply axioms properly.